So everybody, welcome to the Integrated Reflexology Consortium webinar. It is my great pleasure to welcome Kevin, Kunz and Barbara, who's going to be with us as well. We've got over 300 people with us, so if it's possible, if you are able to turn off your camera until we get to the question and answer session later, that will really help with our bandwidth. And ensure that we get a really good quality presentation from Kevin. And Kevin, over to you. We're really excited that you're here. Thank you so much for joining us.
Our pleasure. Barbara's my partner, and we've very pleased to come and visit with you. We've got such exciting news. And sorry for all the technical glitches. I'm not real good with this, but I'm going to try. Let's see here. I want to share my screen with you. Let's see. Okay, we're going to. No, it just.
I can see your screen.
Can you? Is it blocked?
No, I can see it. I can see you in front of it.
There we go. Okay, so we started out, it's going on 4 years now, with a project called Neural Pathways of Applied Reflexology. And what the whole premise is that we wanted to see, when you applied reflexology and you scanned the brain, exactly what was going on. And it was a funny kind of story, because what started out as a client came in, she was very pleased with my work, so she insisted on her husband coming in. Well, Stefan Passi, Dr. Passi, is actually a physicist who specializes in neuroscience. And I could tell from the doorway that he was a skeptic. And so it took a conversion process to when he finally was the one who came up with this actual project. And the idea behind it is that basically what it does, it scans the brain. I'm going to go into a little bit about what a functional MRI is. And what it is it's basically scanning the brain as we apply the technique. Now, what's truly unique about this is that we have real-time imaging going on. So as I'm applying the technique, and that's me in that picture there, in front of a $3 to $5 million machine. We got to play with that. At any rate, so the person would be scanned, and as I was applying the technique, the images would come right through and show exactly what area of the brain was responding. And how do I get through here? Okay. Okay, so this is us. And we're not neuroscientists. We basically just have been doing reflexology for a lot of years. Hate to mention how many. But basically, this is us in front of all our books and so forth and so on. At any rate, we've done 25 books in reflexology. We're in 24 languages. And right now, we're hearing from all over the world. And it's because of this project. What has happened is that people are suddenly getting interested in seeing the research that we can come up with. So this is our research team. And Barbara and I have been around a long time, but we've never been into neuroscience, although we've taken a crash course since we've been involved in this. Now, Dr. Stefan Passi is our lead investigator. He is from the University of New Mexico. He's a full professor, and he's a physicist, but he's also got some, we're using cutting edge technology now to explore this. This is new, and we're using some pretty amazing techniques. Dr. Isa Jakob is a medical physicist, which I didn't even know existed. And so he's helped with the project. He actually helped us amp up so that we've got thousands of images. And then another wonderkin is Dr. Ann Vanderwinkle. And Ann is just an amazing person. She was able to do a lot of the follow-up work after we did the research. And then finally, we've got a new member of our team who's joined. And Luca's a character and a half, but basically he's the one who's doing the data and looking at the data. Now, originally, Luca was a skeptic until he started working with the data. And now he's not only no longer a skeptic, but he also really wants to do a paper on it as well. And so we actually have several papers that may be coming out from this. Anne also wants to do a paper, and obviously we want to do a paper overall from the team. And let me give you another one here. Okay, so we started out, and I'm relaxing a little bit. It was a little tense there for a moment, trying to get hooked up.
Don't worry, you're doing fine now, Kevin. You're on a roll. It's great.
I'm calming down. At any rate, a proof of concept is basically what we're doing is looking at showing, validating the concept of reflexology. And so a proof of concept is an interesting thing because basically what it does for you is it will go through and validate the basic concepts. And so from there, what you can do is go on and do other things. It means we can go on. It's kind of like opening a door. So once we open that door, that means that we open ourselves to new research, grants, things like that, where we can fund this further. And so it's a very important concept, and we did that. The first part of our research was a proof of concept, and we succeeded. We now have evidence that reflexology goes well beyond what they actually thought it would do. And so that's really important. That's part of science. And so we saw unexpected changes in the blood flow to specific parts of the brain. We found changes in blood flows to various parts, and that's what this is all about.
I hope you can see, Kevin. I don't know if you can. There are loads of hearts, thumbs up. There's stuff flying around all over the screen here. So this is brilliant. Everyone's enjoying it so far. So this is good. Oh, and applauses now. More hearts, more applauses. This is good.
Oh, good. Yes. Well, I have to be honest with you, David. This was a thrill of a lifetime for both Barbara and I. We since the early 80s, and we saw some signs when we were working with spinal cord injury, we saw some really distinctive signs that this was working within the nervous system. Now, I'm not discounting other explanations of reflexology, but we knew we could show how it works in the nervous system. And so by doing that, it opens all kinds of doors. It opens the doors to medicine, it opens the door to science, and it goes on and on. I'm going to try to move my window here because I can't see my own stuff.
Oh dear.
Ah, that might help. Nope, that just made me move. Okay. I'm going to go to 5. Okay, that helped. All right, so now we're on to 6. Well, let me go back to 5.
This is what the neuroscientists.
All right, so yes, let me go back to 5. 5 is very important because this is what the neuroscientists said. Okay, so one of the things that was said was obviously we see the major sensory motor areas of the foot light up. That's going to light up. When you touch your foot, that area is going to light up in the brain. But there's nothing, that is expected. But beyond that, we see that all these these other areas, you know, they have nothing to do with the foot per se directly. And the neuroscience question is, what does that mean? You know, why would pressure to the feet elicit a response in a particular area? That is way far away from what we know about the sensory motor area of the brain. And that was from our lead investigator. Okay, so this is, okay, so basically what we come down to, and I brought my friend here, you know, this is a part of the brain they expected it to be lit up right through here or activated. Okay, but it actually activated several other areas as well. And it's going to take us a while to basically go through all the areas it's affecting. So what you're looking at here is the actual brain scans. And the different areas will, when they're activated, will show different colors. And that tells you a lot about what's going on.
Kevin, I'm getting a few people saying they can only see the top picture of the page. There we go. That's it. Can you scroll it up a little bit further so it goes above your head? Because at the moment you're sitting in front of the pictures.
That's me.
Can you get this to go full page, you know, on view?
Yeah.
Full view. Where's full? Where is it? Yeah, okay.
Try going to that green button on the upper left and see if that takes the screen up all the way up.
Yeah, it's okay. We're on pages, so we're dealing with it that way.
So,
Can you do it?
yeah, I can get to pages. I'm on pages right now. Okay, let me see if I can.
But you need to be on the spot.
No, that's it. We can see all three pictures now.
Oh, good. Get my big head out of the way.
I didn't want to say that, Kevin. You said it.
What's that?
Kevin, hi, it's Judith here. I
Yeah.
think there's a presenter setting that you can change. If you go into your settings, there are presenter settings that will mean that either you're on the screen or you're not on the screen, or the pictures of people in the meeting will be moved around. So you might want to have a look at that.
Okay. You know what? I can shut. How about
Thank you,
shutting down my
Judith.
camera? Oops. Can you see me?
We can't see you. We can see the presentation now.
Oh, good. Okay, that's all that counts. Okay, you want to go on to 7?
Let them see the pictures.
There.
That's it.
Can I
Okay.
see something? You
Yeah.
gotta make that bigger.
Okay, can you do it?
Okay, hold on. We are trying to get your picture bigger here. Oh, okay, here we go. Let's see if this is that too big? We can do it.
A little bit smaller.
Okay, we
Only a
will
little
go.
bit.
Here we go.
If we go 150, that might just.
Yeah, there we are.
There we go. So as you can see, it lit up a bunch of different areas. And what we really got from the neuroscientists and so forth is it went way beyond. This is called the sensory motor cortex. This has to do when I touch you on a certain part of your body, you're feeling it, you're going to feel it along this area. And what it is they call it the homunculus, or it's a little man. So you've seen these pictures where you've got these this odd-looking creature with big hands, big lips, and so forth. Well, that's basically telling you how the sensory is coming in. And then there's another one that comes with the motor, and it basically is sending the motor responses out. And so this is what they thought. That was it. They weren't going to see anything else. And in fact, what happened was it went well beyond that. which we're going to describe in a minute. But I want to tell you a little bit about the study. So we started with the study in April of 2023, and it was at the University of Minnesota. And you know, there's a term, you were in the room, we were in the room. This was actually as the scanning was taking place. Barbara was in the control booth. I was in the with the machine, and basically we had a team of people that were actually working the whole settings and all that. Is that better?
Yeah, that's good.
Okay, so this is the first part. The first part was in April, and this is where we did the proof of concept. And so very cleverly, we went on in September of 2023 and started working with a clinical application reflexology with stroke patients. And what they did was they brought the April people together with the people in September, the stroke patients, and came up, the people in April became the controls, the healthy subjects, and then you had the stroke people. And so they had quite a bit of different, well, there were some similarities and there were some differences. And they said each one of them had significance. And so this May, just this May, on the 6th, Stefan, our lead investigator, flew to Singapore, and he made a presentation to 5,000 scientists in a worldwide conference. It's called the International Society for Magnetic Resonance in Medicine in Singapore, and made the presentation showing how reflexology affected the brain. So this is the actual facility we were in. It's a school of medicine, and this was the lobby as this first picture. And it was a really interesting experience, because there's the facility. They have 11 scanners. They have scanners that are so powerful, people, you got to be careful, because people will levitate. It's got that much magnetism in them. And so, and while we were sitting there, funny enough, they came through with a whole cart full of heads. So they take these, they're mannequin heads, and they would put them in the scanner to adjust them and things like that. So it was quite an interesting experience. So this is the actual scanning. We had to take a course. We had to become biomedical research investigators in order to actually enter this room. You got heavy magnetism. What's that? Yeah, we had to take courses, and I got to tell you, we're pretty rusty, but we took these courses just to get in the room, because you have to know all the different parts of this. That scanner is so powerful, it'll pull a watch off your wrist. You know, they tell you horrible stories about what happens if you don't completely devoid yourself of metal. Any rate, so this is a healthy subject, and they go on to the bed, and then the bed moves in. And
The
then
table, not a bed.
Table, okay. Good choice of words. At any rate, so then you can see I had headphones on. Barbara was calling out the time as we went through it. And I also, it's a noisy place, so it kind of blocked out some of the noise. Okay. So this is the control room. Kind of reminds you of when they're launching a space flight or something. But that's Stefan. And that's Isa. And so they were working at the same time to get the images up.
So you can see.
So you can see, if you look at the bottom picture there, they're seeing the scan or the person's brain as I'm working. Would you go up to?
150.
It's a little different when you're working with a stroke patient. You can't quite, just get them to jump up on the table and slide in. You have to work with them. And so we had a team of 3 just to get them up into the machine. Now, if you'll look here, there's a chair. And that was pretty funny because when we started out, we knew we had to get up high enough in order that I could apply the technique. And so we came up with a contraption that was like bed risers and a lawn chair and da-da-da-da. Any rate, so Wendy, who's worked at this facility for 36 years, said, "What are you doing? Here." And she goes out and gets a perfect chair to sit in there. And hopefully someday we'll see some of you in that chair. At any rate, there are problems that, we are interested in actually doing some further research. And one of the areas is spinal cord injury. The problem with that is that if somebody moves, the image is no longer any good. So it is a problem. You have to have people lay still and so forth. So this is the team. This is kind of after the scanning. And here I am. Anne and Stefan. Barbara was unfortunately taking the picture, so she's not in the picture. But here's the part I like. There's the actual images that we were pulling up. And it's kind of interesting. I grew up in a family of physicists. I'm now back with the physicists. And they had all kinds of insights into what was going on. So what is an fMRI? It's an interesting process because basically what you're doing, you're probably familiar with MRIs. They're showing the structure of the internal body. Hello? At any rate, what a functional MRI is doing is it's looking at the blood flow that is going on in the brain. So it's oxygen and glucose and so when you get oxygen, when you get a burn, as they call it, you basically show that the blood flow is going to specific parts of the brain. And it's sexy. I mean, it's really sexy. It's one of the sexier things going on in neuroscience at this point. And so it measures the blood flow and the oxygen and changes that occur. When do you sense, feel, emotions, or even nothing? During an fMRI scan, pressure the feet, for example, show a change in blood flow to a specific part of the brain. So the results of the brain scan are images of blood and oxygen flow in the brain. And that's what you get. And that's actually as a person's being worked on. So what we did, we had 4 healthy participants. That was our first with the proof of concept. And so what we did was we applied technique to the left foot of each reflex area with what's called an on-off block pattern. So it's 8 seconds on, and then there's a pause of 12 seconds, and then you repeat that for 5 minutes. So overall, we were really not applying a lot of technique. That's why it's so interesting that it caused so much change. But we picked the different areas. There's the pituitary reflex area, eye reflex area, vagus reflex area, adrenal gland reflex area, temporal lobe. This is with the healthy subjects. Now, we went on and we had 4 stroke patients. That was the next round. And I got to tell you, part of the problem was it was harder to work. you know, you had to make a lot more adjustments. And so we got to, basically we worked left and right foot. And then we went back to that block pattern, which was 8 seconds on, 12 seconds off. And we worked the eye reflex area, the vagus reflex area, brainstem reflex area. Now, these areas were of particular interest to us because of all our years of doing reflexology. And the reason why we selected these areas you know, some of this was just plain clinical reflex experience, let's put it that way, but it was our exposure to different reactions people had. Now, the pituitary area was particularly interesting to us because I think it's way beyond pituitary area. It has a lot to do with a lot of different things. Well, this is the one we've used with resuscitation, and we've, basically revived 2 people who showed no signs of life. So that was of particular interest to us. The eye reflex area, I actually think of the eye ear reflex area is so much more than, just the eyes and, ears. To me, it has a lot to do with kind of a neural pathway that's very strong. I call it my magic area. I use it with a lot of different things. In fact, that's one of the reasons why stroke became of interest to the neuroscientists. I've been able to get somebody to move the paralyzed limb within 1 session. And you're going, well, how's that work? It's not just the eye area, obviously. And so that's one we want to study and study even more. And then the vagus reflex area, you've probably heard a lot about the vagus nerve. It's kind of become a real star as far as body parts go. But this is only a part of the vagus nerve that I focus on. And it's the part that goes through the chest and the lungs and innervate the heart and so forth. And so we did that one. And then the other 2 we did as a result of previous, we're not the first to do fMRI studies, but there were previous studies. And so we took their particular approach. So they did the adrenal gland reflex area and the temporal lobe reflex area. At any rate, with the stroke, we did a little different. We did do the vagus, we did do the eye, and then we went for the brainstem as well. And so that's where they got some pretty startling results. So here it is. It lit up. There were 3 areas in particular that were so exciting. And basically, might bring it down a little. Okay. So these were common with all subjects. We'll talk about that in a minute. But there's a supramarginal gyrus, believe me. We're learning these parts now. What's called the pre and supplemental motor areas. And then the last one is the insula. Oh, sorry, I skipped one. Insula is up above. Insula, supramarginal gyrus, and the pre and supplemental motor cortex. These alone are fascinating. I tell you, if you want a hobby, study the insular cortex. It's an amazing part of the brain. Okay, now this is the results from the stroke. And again, it affected the insula. No, it affected, I'm sorry, the supramarginal gyrus. It affected the pre-supplemental motor areas and affected the middle temporal gyrus. Those are very significant areas. They have a big impact on the integration of movement and things like that. So to compare the results, there's quite a bit going on. So when we applied with the healthy participants, when we applied technique to the pituitary, eye, vagus, adrenal, and temporal lobe areas on the left foot, activation was prompted in the areas of the brain consistently across all subjects, all participants. And this interested the neuroscientists because basically it was repeatable. You could do it, and it always tended to do the same thing. So it lit up the foot sensory motor cortex. It lit up the left supramarginal gyrus. It lit up the insula and the pre and supplemental motor cortex. Now the stroke patients. So again, we did the technique applied to the vagus nerve, the brainstem, the eye reflex areas on both right and left foot. The activation prompted areas in the brain consistently across the study participants. So again, you went for the foot sensory cortex, you went for the pre and supplemental motor cortex, the left supramarginal gyrus, and the left temporal lobe. Now I'm going to tell you why those are significant. And by the way, we're going to tell you, these are only two of the areas, or just a handful of areas. There's a lot more they're delving into, because they said, I'll quote Stefan, he said it lit up, or it activated like a Christmas tree. Yeah, so this is the fun part. This is what's got them talking. They were blown away by this. The consistency of the finding across the subjects are great. I was amazed to see the strength of these signals. And so there are apparently a lot more than we thought. And that was Stefan. And then Anne, we demonstrated feasibility and reliability in the brain activation, given that there were common brain activations among both groups during the session. You know, they called I won't forget the day that Stefan talked about the results. He said, "This is beautiful data." And they talk about the robustness of the response. And that's the exciting part, I think, for reflexology. You're not just tickling a foot, you're actually activating parts of the brain, very significant parts of the brain. So the other thing that got him was the fact that the same brain areas for the healthy and the stroke participants, it activated the same areas. And the consistency of the results was noted as important by the researchers. Foot reflexology applied to all reflex areas activated the same parts of the brain. Why? Why did that happen? That's what's got him. Is reflexology activating parts of the brain involved in a specific purpose? This is what we're going to have to go on to, because I can't tell you that it's going to solve such and so problem or whatever. That's where they're going to have to say, well, that would be connected to this area of the brain that got activated. Or would specific reflex areas activate specific parts of the brain as change in the future study parameters is needed? We need a stronger machine. We're already talking. We did what's called a 3 Tesla. They're going up to a 7 Tesla in the next round we're talking about doing. And we need to refine the protocol. There are things we could have done that could have been better. And every study is going to have things that say, here's the limitations of them. And our limitation is, yes, we had a small population. So we're perfectly aware of that. We're not trying to dodge that issue, but what we're saying is we got started. This was a pilot project, and we got it at least off the ground. Now, this is what I do on weekends. I really do enjoy the insular cortex. And okay, one of the things that's very interesting about the insular cortex is Stefan at one point called it the seat of consciousness. And it has to do with a lot of stuff. There are too little, I can't even show you on this model because it's buried deep in the brain. And their size, there's one on each side, and they're the size of prunes. And so if you look at them, you got to cut into the brain to actually find them. And so they have a lot to do with a lot of different things. And I think, by the way, this is our crossover. If you want to talk about psychological implications, it's the insular cortex, because the insular cortex has to do with what's called interoception. And so if you're not aware of it, learn the word proprioception. Proprioception is the stretch of muscle, angulation of joints, and interestingly enough, deep pressure to the bottom of the feet. And so proprioceptive signals are coming from the foot as we apply our technique. And that we know. Interoception is the sensory information from the viscera, the lungs, the heart, the organs of the digestion, excretory, and reproductive systems. And so the insula has real input on that. Hearing, sight, taste, all kinds of different things. Love, lust, hate, frustration, feeling of belonging, homeostasis. It has to do with guilt. It has to do with all kinds of different emotional factors. So it's kind of helping regulate all that. It's a kind of volume control. So it kind of turns things up and down. You know, I mean, we have to be aware of our surroundings. We have to be aware of our environment around us. And if for instance you are faced with an enemy, that's going to have a different setting on your volume. And so it controls the autonomic nervous system through regulation of the sympathetic parasympathetic system. So we're constantly in a state of fight or flight. Well, we need to turn that off for a while, and that's where the parasympathetic or rest and digest system comes in. So it has a role in that. It has a role in regulating the immune system. It has a role in the sensory motor processing. It has a role in auditory and balance functions. It has a role in perception of pain, feelings, emotions, disgust, fear, anxiety, and happiness. If you are a smoker and they stimulate the insular cortex, you will stop smoking. Unfortunately, they don't know what else it'll do, so they're not really jumping up and down about, stimulating the vagus, insula. But there's other things. If you have food in your mouth and they stimulate the vagus nerve, you'll spit it out. It has to do with all kinds of that type of thing. It also has to do with our risk aversion and reward. They say really good people at finances often have a well-developed insular cortex. And then the other part about it that's going to be very interesting is it plays a very important role in psychiatric disorders, addiction, anxiety, autism, schizophrenia, depression, neurodegenerative disorders, obsessive compulsive disorder, panic, PTSD. So it's involved in a lot of different types of psychiatric type of things. So that's one of my favorite. Like I said, it's my hobby. Now this is another part of the brain. Barbara and I are learning about this because it lit up as well. It's called the supramarginal gyrus. So you've got back in here, you have the parietal lobe. And the parietal lobe has fascinating amount of different processes it helps with. It was very interesting. Albert Einstein, the brain split in two parts. His parietal lobe was joined. It has to do with mathematics. It has to do with a lot of different things like that, but it particularly has to do with proprioception, or our ability to sense pressure and stretch and movement and so forth. It has to do with hearing. So you actually, the types of sounds you hear and making sense of them, sight and touch. So it forms a coherent perception of the environment. It's where your body is in time and space. Barbara and I years ago wrote a book, and one of the lines I was very fond of is, in order to move, you must be able to see yourself. You must be able to, this hand, if I'm going to move it, I'm going to need to know where it is. And so it has to do a lot with body perception, how your body moves and what it moves in relationship to. If something's very close to you, you better pay more attention to it. So that it has to do with survival. Yeah, we're right here. Right there. This is the middle one. And so it has to do with spatial processing to perceive, interpret, and mentally manipulate visual and spatial information, motor planning, organizing, and coordinating motor movements, helping to plan and execute skilled movements such as reaching, grasping, manipulating objects. It has to help process language, and it's also involved in memory storage. So the fact it lit up has got us going. We're trying to figure out what's going on with this. But it does, and part of the interesting thing Ann said was, this has to do with a body-mind connection. So is that where it takes place? Then another place lit up too, which we're just learning about at this point, but oops. It's called the premotor and supplemental motor area. Movement's a pretty involved thing. And so we have these areas that help regulate it. And that's the premotor and supplemental motor areas. And they make movement possible. Without them, we'd have a lot of trouble. So the premotor area anticipates and plans motor movements based on cues, what's going on the outside. And then the supplemental is involved in self-initiated actions like throwing a ball, rising from a chair, those type of things. So they're different in essence, but they do tend to work together. So they, our survival, and I'll tell you about a very interesting conversation I had with Stefan. He said, survival is the prime directive of us. We have to have survival front and center. And I said, yeah, and locomotion is our way of getting there. There's a saying, I loved it. Somebody came up with a saying that you can either go out for lunch or you can become lunch. And that's what survival is about. We have to protect ourselves. And so movement can be critical. And so this is what's helping regulate movement. So if you look here, if you see the orange, the premotor cortex is going to be in the front of that. If you look at the greenish area, it's going to be right through the middle, right through there. So one of the things to do, it's pretty tricky to do, is to plan complex movement. And you also need to have a stable posture. I tell my people, I say, well, if you don't have And by the way, the speed at which signals are coming to the feet to the brain is about 15 to 30 milliseconds. And so if you don't have the proper communication going on between the feet and the brain, you're going to fall down. It's an all or nothing type of thing. And then the other part about it is you need that type of signaling going on. So you coordinate both sides of the body. They work together. And then also that you can control the sequence of movements that you are performing. Now this one came up with the stroke people. And it's called the middle temporal gyrus. And it's involved in what they call multimodal sensory integration. And this could explain the processing of the sensation reflexology and understanding of the brain where the body stimulus is applied. So in other words, we saw changes within the stroke people, and we needed an explanation. And the temporal lobe of the brain is really interesting because it has a lot of impact on a lot of different things. Memory, understanding language, experiencing and processing emotions, processing sensory signals, especially sight and sound, visual recognition, such as familiar faces and objects. They actually scan me. And people ask, well, what did they find? I say, nothing. But in fact, what they saw were two things. One was that my verbal areas started to light up. And then they saw my facial recognition areas. And all I was doing was I was visualizing doing a reflexology technique. And for some reason, the facial recognition part of the temporal lobe lit up. And so we're still trying to figure that one out. Okay, the middle temporal lobe is the earliest region to display atrophy in the course of Alzheimer's. So we're going to be talking about the future, but that's one of the areas that's significant when you deal with Alzheimer's.
You want to go back here?
Okay.
17.
I'm going to go back a little bit. And let me get this. I guess we're at the right, so down below. Okay. When we were testing the stroke patients after reflexology and the fMRI, the results compared to testing before, we did, let me restate that. We did a before and after. And basically we tested the hand. And basically we were looking for 2-point discrimination, which tells you a lot about how capable the sensory is performing. And then we also did the muscle tone. And so it showed that it improved the muscle tone quite a bit. In fact, one man was able to totally relax his hand. And as Anne put it, it was awesome what she saw with the improvement of the 2-point discrimination. Is that? Okay. Okay, this is my favorite, is the theory. Okay. I don't think we're alone. This is just one study, and I think it was a good study, but nonetheless, there's been other studies. And so here's the theory. And what would the body's purpose be if foot reflexology activates the insula, the supramarginal gyrus, and the pre and supplemental motor areas? Well, okay, that's a bunch of words, but let's try to break it down. So part of this is the proprioceptive information that is sensed by the foot. We think of it as an evolutionary system. It helped us to regulate and survive. So when we start if we see the saber-toothed tiger, we better start running. So then suddenly we're going to need more oxygen. So our body's going to have to make that adjustment. Well, there was a very interesting study by some UCLA researchers. And, one of the things that's known with neonatal people is that if you want to start a baby, if a baby stopped breathing, you want to start them breathing again, you tickle the foot. And so they liked that idea, and so they utilized it to target breathing regulators, particularly the brain cerebellum, to research interrupted breathing in premature infants. And they successfully used a device that sent proprioceptive stimulation of vibration to the feet, and they affected the breathing apparatus. So what we're looking at is this is all about survival. So if you can get that simple a result just working on a baby's feet, imagine what you're doing in a whole reflexology session. And now imagine we were doing 5-minute segments when we were working. So the idea of that was to show a proof of concept, but it really doesn't show what happens with a full reflexology session. When you're thinking about all the things that are going on, it's amazing. So yeah, that's what we got to do. We got to survive. That's the prime directive. And so if we're going to survive, we need these, what the neuroscientists talk about is connectivity, the ability of different parts of the brain to connect. And so we're very excited. Now, we have more to do, but the supramarginal gyrus and the premotor area play a key role in proprioception. They're one of the stars. And, it's very important to have spatial processing and things like that. Otherwise, you're going to maybe not survive. Okay, so let's take away that signal and see what we have. And so one of the things, Barbara is quite a researcher. She digs in and digs in and digs in. And one of the things she came up with is what's called a Corvid boot. See, okay, so the Corvid boot was developed by the Russians. And so when you have a brain in space, or you have somebody in space, and they don't have gravity, it tends to send the system into chaos. And so they thought, well, what if we develop this boot to send in these signals and to simulate a footstep, basically. And so they developed this boot. And one of the things they discovered was that if you use this stimulation, Barbara can tell it better than I can.
Well, when the cosmonauts returned from space, they tested them in an fMRI machine using the Corvid boot, simulating a footstep. And what they found was alterations in the brain, visual, proprioceptive, vestibular networks, and notably in the posterior supramarginal gyrus.
Okay, so what's that? Okay, so they got less space sickness, right?
Yes, those who showed the greater change in supramarginal gyrus got less space sickness. And when they initially go into space, it takes at least a third of the cosmonauts and astronauts 3 days to get over being nauseous and feeling dizzy.
At any rate, so this is not without precedent, but it's interesting that they're lighting up the same areas that we saw in our study. So that in science, that's a good thing. You want to, instead of being novel, you want to have a repeated pattern over and over again. So that's basically what we saw when we were doing this research project. And I'm going to talk a little bit about the future and what this means. Okay, I think we're all going to get a pay raise is my theory about this, and that would be nice. because we're going to get more respect, more prestige. We're going to be seen as not just kind of this weird practice. And by the way, my joke is that people are always looking down on their feet. Well, we're going to elevate the feet to a new level. If you really want to get a skeptic angry or crazy, I'll tell them, well, you know, the foot's a part of the brain. And that just drives them nuts. And you're going, well, what's the brain without sensory organs? The feet, the ears, the head, and so forth. All the sensory portals. It's nothing. It's just a 3-pound mass of jelly. And so I think this is a real opportunity at this point. If we can keep this research going, and it's very promising at this point, they're already applying for grants. And we can become an adjunct to medicine. I don't really want to take a full responsibility of a patient's health, but I'm more than happy to be an adjunct. And I think this will create new opportunities to address things like aging, child development, stress, stress disorders, mental health issues, chronic illness. One of my favorite blogs we ever did was called Barefoot Baby Brains. And what that was we were taking a Chinese article and putting it through Google Translate, and it came up with barefoot baby brains. Well, the Chinese and the Japanese are looking at the feet and stimulating the feet as part of neurological development. And you're going, kids need help nowadays. It's a tough world out there. Well, what if you could help them with stimulation to the feet, the hands, so forth and so on? At any rate, could we change the course of their lives? And I think we could. So what do you see as the future of reflexology? I'd be interested to know. And what inspires you the most? Because I got to tell you, I started out in April of 2023, and I frankly was, not exposed to the world of reflexology, and how it has grown. I didn't realize reflexology was in all these countries, and then there was all these different approaches and so forth and so on. And here we are. We're now in a new world, and I'd say that there's responsibilities when you enter into medicine and science, but there's also great benefits. And I think that's what I'm looking forward to. Thank you, and we'll take questions if you'd like.
Kevin, that was absolutely excellent. Thank you very, very much. What I would suggest, Kevin, if you stop sharing your screen so that we can then see you. But the first thing that I'm just wanting to quickly ask, and we will take questions from as many as we can fit in. And in fact, that if we get the questions coming up on the chat, and then I can go with that. First question that we've got here it says, thank you, Kevin. Will there be an academic paper published?
Yes. Yes.
That was a quick answer, wasn't it?
Yeah. No. We're planning on that.
Yeah.
Trying to stop sharing the screen. Let's see.
If you go top right.
Yeah, there it is. There we go.
There we are. That's it. Okay, excellent. So guys, being as we've now got pictures of people, if you're wanting to be able to see who the speaker is, if you've got lots and lots of little pictures on there, if you just go on to view and then go on to speaker, you'll be able to see who the speakers are. Question I've got, Kevin,
yeah.
And this might be a very stupid question. I'm a complete layman when it comes to research. Am I right in thinking that when you are applying reflexology, when you've got somebody in the MRI machine and you're applying pressure to the feet, you're expecting to see a response in the somatosensory area of the brain. But what you were finding was that there were actually responses in other areas that weren't expected. Is that what? Yeah, I can see Barbara nodding her head. Barbara, it's great to see you, by the way, as well.
That's it. I'm going to move over a little bit. Yeah, no, that's it, because basically this was not okay, David, we see a real flaw in the whole neurological paradigm. One of the things that when we were talking to Stefan at lunch, he said, this is not only going to change the way we view reflexology, it's going to change the way we view how the human body operates.
Mm-hmm.
They don't really take in, and it's been a real interesting journey, because we're totally unique. They're used to testing, fingers and so forth and so on, but they're not really used to applying technique to the feet to show what goes on in the brain. So this is a unique adventure.
No, they were blown away.
They were blown away.
Scientists were. They thought it would just be the foot area of the brain activated.
Yeah, this area right here, right in through here.
Frankly, they're still trying to figure it out. We showed areas of the brains that activated. A lot more is going on. They talk in terms of networks. So they are still trying to figure out what networks were activated.
Perfect. Can I just bring in Judith Watley? Judith, I know you asked a question. I can't see it on the chat anymore. Could you ask Kevin?
Sure. Yeah. I think my mic and camera are back on. Hi, Kevin. Hi, Barbara.
Hi, Judith.
Thank you. It's lovely to see the images at last, and to hear you talking about the research. I'm just wondering whether there was any crossover effect, because I know there's been some research done on MRIs previously, and reflexes have lit up in similar places to your research. But some research shows a crossover effect. We're generally accustomed to the right foot reflecting the right side of the body, but in some brain research there has been an opposite side lit up in motor or sensory, I can't remember which, gyruses. Did you find anything like that, or was it?
Yeah.
The
supramarginal gyrus lit up bilaterally, both sides of the brain.
But it wasn't specifically a crossover to left or right. It was bilateral.
On the supramarginal gyrus.
On
the others, yeah, it was
on the others,
crossover.
There was a crossover.
Yeah.
Yes.
Okay. Yeah, it's very, very interesting work. Yeah. Thank you.
Judith, one of the things that prompted us is when we were working with a spinal cord injury, we'd work on one foot and the hand on the opposite side with the quadriplegic would move.
Yes.
When we worked on a paraplegic, you work on one foot and the foot on the opposite side would move. And so, we're very interested, and they're far from distilling this down yet. They're still looking into why it's doing what it's doing.
Yeah.
So we're early days.
Yeah, there's an awful lot of work to do.
But I'm not doing.
Thank you.
It's good to see you. And
you too.
I read your papers. I enjoy them.
Thank you.
Okay, there was some questions about the on-off timing. I can't remember who asked them, but I know Linda Frank, I believe you asked something similar. Can I just bring Linda Frank in?
Sure. Hi, Kevin and Barbara. Hi, David. Hi, all. I was wondering, on the 12-second pause on the block technique, were you reflexing other reflexes, or were you just holding the foot and not breaking contact, but just pausing?
Yeah.
No, Kevin wasn't actually, I guess you were holding the foot.
I was holding the foot, but I wasn't applying. This
has to do with the fMRI. This is the way you input a task to the machine. This is their design. It had nothing to do with inputting reflexology.
Yeah. So what it does is it gives you a gap, and there's significance to that. And I think they're still working on that one. But does the effect of the technique application continue, or does it just drop off? So there's other implications to that.
This is their their demand.
Yeah,
Had
that's,
nothing to do with applying reflexology.
this is not the way I would do a technique. I mean, a session. You know, Linda, I'd be working here and then going there, but they apparently wanted to isolate specifically what that signal was when I applied technique.
Okay, thank you.
My pleasure. Good seeing you, Linda.
Likewise, one more question, if I may. I thought I saw that the insula was not lit for the stroke patients, that the others were similar. There were 3 or 4 areas that were similar, and the insula was not included. Is that the case?
It didn't seem to activate. Now you'll notice we worked on 2 different sets of reflex areas. Maybe that's it.
Yeah, they're still looking at that. Because one of the things that they want to figure out is exactly the difference between the healthy subjects and the stroke people. Where did the differences lie?
Okay, thank you. So to be continued.
You got it. Good talking to you.
Now,
Likewise.
I have at random come across a very interesting question, Kevin. So can I bring, is it Lemurs Our Life in? It's about touch in general.
Okay.
Is Lemurs Our Life here to oh,
I just had a quick question about the actual touch on the foot as in reflexology. Did you at any point touch anywhere else on the body, the leg or anything else to sort of see if
No,
a similar
can't.
thing applied?
Their whole body is in the fMRI machine. There's nothing else you can touch.
yeah,
Okay.
and I did. They wanted to again isolate to a specific area on the foot and show exactly what that contact was doing.
But if you were to work on another part of the body, what they do is they do the work, then the individual goes into the fMRI machine, and then they
Okay.
judge what has
So
happened
we
beforehand.
can't positively say that if I touch, say for example, halfway up their shin, that the touch from another person would fire up those same areas of the brain as
There's
well as
a-
it
there-
doing
No, it wouldn't, because you've got your sensory motor cortex would light up in another part of the brain. Plus, our basic premise is the foot is special. The foot participates in walking. Therefore, sensory pressure to the foot is special and different from pressure applied to any other part of the body.
It's like one of the questions I have is because the pituitary area is right at the joint. So when you're taking a footstep, the last part of your foot to leave the ground is the big toe. And there are studies, if you want to delve into it, there are lots and lots of studies about, the impact of stimulating the big toe, including that it'll actually promote what's called gamma waves, or waves that are kind of very good, conducive for parts of the brain working together. So no, we're being reductionist in a way. That's not to say that if you stimulate other parts of the body, they're obviously going to light that area up. Even touching the foot will light some parts like supramarginal gyrus and so forth and so on. But the point is, these were robust signals. They didn't expect that type of response.
Brilliant. Thank you very much.
You're welcome.
perfect. A great question from Janet about the areas from the control group and the stroke group. Janet, are you there to be able to put your question?
Yes, I noticed when you were comparing the control group and the stroke group that you quoted that you had touched different reflex areas on the feet. Now, perhaps that's all you've told us. Perhaps you did all the same on both, but that's where you got the response. But I wondered if you didn't work exactly the same on the control and on the stroke group, are you actually comparing like with like?
No, they were, go ahead.
Okay, quite frankly, the stroke group came along after we had completed the control group. Okay, these were just healthy participants. Then we were given the opportunity to work with Anne, who is a specialist in physical therapy and stroke. And so we chose areas for the stroke group that we had found clinical results with.
Okay, great, thank you.
And you know, it's a little tricky, to be honest with you. When you're working with stroke patients, it takes time. And when you're on a scanner, they're very expensive. And yeah, we have other ideas of where we'll go back and improve.
Yeah, I suppose just from the point of view of publishing a paper, on it, you'd want to be comparing like with like to show when you go forward to show.
Oh yeah.
The responses, particularly if you're calling your healthy group your control.
Well, that wasn't us. That was done by the researchers. Yeah, I frankly glad I'm not doing that part of it. But
no, we originally went for proof of concept, and then we met somebody while we were in Minnesota last April, and they said, "Oh, you should talk to Anne. This is just her kind of thing." So it went from there.
Yeah,
That's great.
and
Thank you. Sorry, go ahead, Kevin.
No, I was just going to say thank you.
You're welcome.
Appreciate your question.
Now we've got a two-part question here, Kevin, and this is from so many people, and they're all asking the same question. So the first part is, how did the presentation go down by Stefan Posse in Singapore? And then the second part of the question is there going to be a copy of the paper available for what was presented at Singapore?
Let me take the second part first. Yes, there will be. There will be a paper. When it happens, I'm not in charge of that part of it, but we haven't gotten feedback from Singapore yet. I'll put it up online when we do.
Excellent.
Yeah, Stefan's out boating and having fun in the Philippines, so we haven't gotten word back yet.
Okay. There's another question as well. This is a good one, actually, because some people do what's called bilateral reflexology. In other words, both feet at the same time.
Yeah.
Some people work one foot at the same time. Oh, I can see you're going to be plugging in your
Yeah, we're about to run out of juice.
I saw your battery a little bit earlier on. I'm glad you're going to do that. We'd hate to lose you. But yeah, so did you use any bilateral reflexology, or was it just one foot at one time in this work that you were doing?
1 foot at one time.
1 foot at one time.
Yeah, I should note the paper that was presented in Singapore is part of a presentation to a conference. I'm not quite sure what the copyrights or procedure is. I don't know if that exact paper will be available to
But we'll give you
us in the general public.
We'll give you feedback.
Great.
And one of the things about bilateral reflexology, suddenly I've been in the dark for a while. We just do our own thing and so forth. Then when I got on Facebook, I realized there are all these different approaches to reflexology. The good news, you don't have to go to me for an opinion. We're now in a fact-based setup. So we can actually, I'll be talking to Stefan, and I was talking to him. I said, well, this is what happened with stroke. And I told you, I was able to get people to move their paralyzed limb within one session. And he said, that means one or two things. Either you got another system we're not aware of how it's working, or what's called neuroplasticity, or the nervous system's ability to quickly adapt is much faster than we ever thought. And he said, but you know what? We can test it. And that's the exciting part about this. I don't have the perfect reflexology session. I'm not that egocentric. But what I'm saying is, the fact of the matter is, we now have the opportunity to test different things. I'll tell you another quick story. One of the ways I hooked Stefan in, He would come in, I'd work on his feet, and he'd fall fast asleep within minutes. And then after a while, he thought, I want to actually experience the session, so I want to stay awake. So if I read, I'll be able to stay awake. Well, the next thing I know is he's got his laptop. It's like a tent on his chest, and he's fast asleep. So one of the things he's interested in studying is the difference between consciousness and unconsciousness. To a neuroscientist or somebody involved in that field, being able to basically knock somebody out that fast is fascinating because it involves certain parts of the brain and certain connections are going on.
I know exactly how Stefan feels.
Yeah.
I cannot stay awake in a reflexology treatment. It is like you get knocked out. It really, really is. So I share his experience. I've got a question that I'm going to read out. This lady. Oh heck! I've lost it. Was it gone?
Rachel Cox?
No. It's somebody that's on a tram and she can't talk because it's a noisy tram. I've just gone and lost it. Oh dear, oh dear, oh dear, oh dear. This is frustrating. She was asking about the crossover. I'm scrolling through. If somebody else wants to ask a question, please just dive in. I'm going to go back through the chat and find this question because it was really interesting. Anybody?
Hello.
Hi, Daphne. Go ahead and ask your question.
This is Jeanette from Sweden. Is it okay that I talk?
Yes, please do.
Yes. I have a question. When you meet the stroke patients, was it a long time ago that they have had the stroke, or was it an acute stroke, or how long time have passed when they had the stroke? And another question as well is there in your country something against that you use reflexology in rehabilitation after stroke? I live in Sweden and I'm just new examinated for reflexology. And in our rules said that we are not allowed to treat people with a stroke, which is totally crazy, I think. But
Yes,
is there something said that this should be dangerous? And I know that it is not, but yes, this is my question.
Well, okay, let me try it. My record is, 24 years. We're working on a young man, and he was able to move his foot in the first session. Barbara and I do what we call a double whammy. She works on the hands, I work on the feet. The next session, he was able to move his hand. So 24 years, so I'd prefer they had a stroke fairly recently, but it's not a requirement.
Now, the stroke subjects in the study, as I recall, it was 4 years to 17 years.
And they all showed an effect. So going back to your question about danger, we had a friend from Netherlands, Charlotte, and she was talking about people don't want to work on people who are pregnant because they could cause a miscarriage. Her point was, well, then they shouldn't walk. It's pressure to the feet. We have a tradition of reflexology, but when you boil it down, we're talking about pressure, stretch, movement, and so forth to the feet. And that's what you do when you're walking around.
Now,
so I don't understand
I know this, but this is so crazy but I hope that these results can help us, that we can use it and do some more integrative reflexology here in Sweden. I was working as a GP before, and I'm just now only working with reflexology and ear acupuncture. And I really like to integrate it to rehabilitation and the medicine, but it's
Excellent.
yet not possible in Sweden. But I will do my job to try to integrate it. I used to
Excellent.
work with older people, and I think it's a so good thing to do to help them with everything, rehab and sleeping and everything. Yes.
Well, we have an aging population. We have kids who have been through a pandemic. We have all sorts of wide problems that reflexology could help with. And, you know, we've started out where we've been threatened with arrest. I mean, it's gotten that serious. At one point, we couldn't practice in our own city of Albuquerque, New Mexico, because we would have to go to a massage school that was teaching reflexology with our book, and in order to become qualified to practice reflexology. So we've been through all the twists and turns. But the point is, the more research and data you have, the better your odds are of overcoming some of this. I call them foot bigots and hand bigots and so forth. They are basically saying, no, this is not the way the nervous system works. This is the only way the nervous system works. We're about to prove them wrong.
Thank you very much.
My pleasure. And by the way, we do have a book in Swedish.
Yes.
Yes.
You can write the name, which one it is. I try to write a message here, but it's not working for me because of this. I'm talking. Yes. Thank you.
Great. And yeah, if you can send me a message somehow, I'll send you the title. Plugging my own book.
Yes.
Disgraceful.
Thank you.
Kevin, you're shameless.
I know.
I have. I still can't find this question that I was looking for. It seems to have disappeared. There was a question here where somebody was asking about their husband who's got double vision, and they were actually asking for some advice from you. If that was your question, could you come in, please, and ask Kevin?
Yes, hello, my name's Teresa. I asked the question.
Excellent. Go for it, Teresa.
My husband, who is just 80 now, suddenly had double vision about 3 weeks ago, and it just happened. He doesn't have high blood pressure, or he didn't have a head trauma, nothing. It just suddenly appeared. And I've worked on him with reflexology. It seems to help it. It's sort of, but it goes back. That's the problem. It doesn't hold. When he wakes up in the morning, his vision is almost okay. The image is closer together. It's not such a double vision with the image far apart. But over the course of the day, it seems to get wider between the ghost image and the set image, if you see what I mean.
Yeah, no, I don't. Go ahead.
So the hospital didn't do an MRI, but they said with all the tests that he didn't appear to need an MRI, but they believed that it was one of the cranial nerves. I think it's the fourth or fifth cranial nerve.
Yeah, yeah. Okay, so one of the areas that's very interesting. I'll grab my foot. This is not actually my foot, but you know, this joint in here is fascinating to me. You know, because this is the place where we did resuscitation. And we, you know, as I mentioned, we've resuscitated 2 people that showed no signs of life, at any rate. So you've got a lot of things going on right here. Well, guess where you get calluses? You get calluses right through here a lot of times. So, you know, I'm be honest with you, I don't have an exact answer for you, but I'd be interested in working quite a bit along the stem of the toe. You know, we tested the brainstem when we were working with stroke patients, and that apparently started things going. The other place I would consider is the other place we tested, which is around the vagus nerve. Now, the reason why I'm saying that one is when you talk about it being progressive, is it going throughout the day? What is happening? Is it the fact that stress is causing an inflammation that is, I'm just throwing it out there, that's causing
Yeah.
an inflammation that,
Well, it's when he gets up, it seems that the image is almost correct.
Sure.
But within about 7 seconds, then it starts to separate.
because he's going upright.
Sorry?
He's going upright. Standing upright is very hard
Standing
to do.
upright, yes.
And so my question would be, is that, you know, I mean, when you stand upright and if you have any type of thing going on in the neck, it might be, and that's pretty well just a guess on my part, but it's shunning off the nerve. So, but see, that's the thing. That's why we need more research.
Yes, he does.
We could-
You're talking about callus on the side of the foot. He actually has there's like a start of a bunion on the
Okay,
left foot on the side of the toe.
but then you're talking posture. So when his posture, he's in the bed, he gets up, he stands up, you're changing your whole alignment and your nervous system and so forth and so on. That would be my 2 cents worth.
He had a chiropractic treatment probably a couple of months ago. We haven't been back to him, but because he hasn't had any back problems before he went to the chiropractor for a back problem, and it resolved. So maybe perhaps a possibility of going back again to the chiropractor.
You know, your guess is as good as mine. And I try to tell you, if I don't have a lot of experience in that area, I don't have a lot of experience in that area. But I would question the cranial nerves.
Okay, thank you.
Certainly. But
Thanks
it's
very much.
ironic.
Excellent.
It's ironic that the callus forms right there. Go ahead.
So I would like, on behalf of the Integrated Reflexology Consortium, to say a massive thank you. And on behalf of everybody that's been here watching you, Kevin, and listening to this excellent presentation, this research that you're doing sounds so hopeful. It certainly sounds as if it's very, very much very ongoing. We're so excited to hear what else is going to be happening. It would be remiss of me if I didn't mention that we've also got, generally it tends to be on the last Tuesday of the month, we have webinars that you can sign up for at icr.training. And we've got Jane Langston coming up with biosensitivity. That's later this month. Then in September, we've got Kelly Hainsworth, how to use Instagram effectively. Lynn Booth, she's going to be with us in October. And then in November, we have Geraldine Villeneuve. So we've got some really exciting speakers coming up. But before we go, if everybody just wants to say a massive thank you to Kevin and Barbara, we are so, so, so grateful. You're wonderful, guys. You really, really are.
Thank you.
for having us.
Thank you for having us.
Thank you so
Thank
much.
you.
Appreciate
Thank
you.
Thank you
for
very
all your
much.
good work.
Thank you.
Thanks,
Bye-bye.
Thank you
David.
so much for your
you.
work.
Thanks,
David and Kevin.
Thank you.
so much. Bless you, bless you.
Thank you.
It was wonderful. Thank you.
Thank you.
Take care.